Hello my dear students, this is Akash SD. Welcome to the AHD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Gravitation asked in a JEE 2025 exam, and this question will be based upon the Kepler's third law. There are total 3 laws of the Kepler, and this is based upon what I told you, Kepler's third law. This is also called a law of periods also. Okay, so let's go through the question. The question is here: if a satellite orbiting around Earth is 9 times closer to the Earth than the Moon. Very important key point. What is the time period of rotation of the satellite? Okay, and after that what they are telling? Given a rotational time period of Moon is 27 days and gravitational attraction between the satellite and the Moon is neglected. That means Moon will experience the gravitation of the Earth and satellite is also experiencing the gravitational force of the Earth. There is no gravitational force between the Moon and the satellite as they told, and even if it's there also, very small, neglected. Okay, so here I will take here, let's take here, this is the Moon here, no? This is the Moon, I have taken here Moon, no? This is Moon here, and here this is the satellite is there. Okay, and after that what is given here? Let's see here. Let's take for example, no? This satellite is 9 times closer. Okay, so let's take for example, if I take for the Moon, no? For the Moon, let's take this is R, or instead of capital R I will write here the smaller, no problem here, no? RM for the Moon. This is the orbital radius here, and all the distances measured from the water center of the Earth. This is the Earth, that's why I have drawn with the blue color. Okay, after that if I talk for the this one here, satellite, and this satellite is having the radius how much here? RS here, is it? And after that if I talk about here the time period, so what is the time period? Time period of the revolution of the Moon around the Earth is how much here? Let's take here, this is the TM, and for the satellite what is given here? Let's take, this is TS here, is it? This Moon and satellite is revolving around the Earth. This is my Earth here, is it? My Earth, or we can tell our Earth here, is it? So students, if we'll see here the question, so we'll just note down the some data is here. So what is the data? Kindly see here. The first data is they are telling that here satellite orbiting the Earth is 9 times closer. That means, for example, if in case orbital radius of the Moon is R, okay, then orbital radius of the satellite, okay, orbital radius of the satellite, what will be there? I can write here, this will be R by 9, because 9 times closer, is it? After that, if we talk about here the time period, so time period of the Moon, what they are telling in the question? 27 days, no? That is mentioned here. Kindly see here, 27 days, is it? Then they are asking what is the time period of the satellite is there, no? This we have to calculate it. So as I have told you, what we have to do, we have to apply the Kepler's third law, that is also called a law of orbits. Okay, so see here, according to law of orbits, remember that here, if in case this is elliptical orbit, which orbit? Again I am telling for the elliptical orbit. Elliptical orbit. In case of elliptical orbit, what happens that here, this T square is directly proportional to this RP plus RA power 3. This is for the elliptical orbit. This RP is the distance of what we can tell, perihelion from the sun, no? In a Kepler's law actually, and RA is the distance of aphelion from the sun, no? That is the very basic game. But here if we talk about here this question, in this question what kind of orbit is there? Here the orbit is the circular orbit. Now nothing is given, that means that is the circular orbit, and for circular orbit the situation is very simple. And what is this? In this situation this time period will be directly proportional to R cube. This formula will use here, now for the circular orbit. Kindly see very well, is it? So now T square directly proportional to R cube, no? So if we'll go to the next page, what can I write here? So as we know that T square directly proportional to R cube for the circular orbit here. Hence, if I write here T satellite by T Moon square is equal to R satellite by R Moon cube here. Is it? Very simple. After that, what can we write here? Kindly see here, this Ts by Tm whole square is equal to R moon, what is given here? If in case R moon is R, is it? So R satellite was how much here? You know very well. They have till 9 times closure. So R by 9 cube here. Is it? Is it? Is it? Is it? So after that, what will happen right here, students? This R and R will cancel out here, and we'll write here 1 by 9 cube. Is it? Now students, after that, I will write here this Ts by Tm. Okay. It will become here. This 2 will go this side, so kindly see here, this will become here 1 by 3 square, and here it will become here 3 by 2. No? If I will take the square this side, it will become 3 by 2. Is it? So here what will happen that here, students, if I will just use here the exponent somewhat here, so this 2 is there, no? This 2 will come here, 2 into 3 by 2. Is it? And here what will happen that here, this 2 and this 2 will cancel out. Very simple. So hence, if I write here the Ts, it will be how much here? Tm will come this side here into 1 by 3 cube. What is coming here, students? This will come here 1 by 3 cube. Now after that here, if I write here the next one, so this Ts will come here, that means time period of the satellite. Tm how much is given here? 27, and into 1 by 3 cube is also how much here? 27. So 27 into 27, 27 into 1 by 27, what is coming here? 1. And unit will be same only, what is coming here? 1 day. That means hence we can tell here time period of the rotation of the satellite around the planet. That means in our case Earth, what is coming here? This is the 1 day here. Is it? This is the answer. And remember that here why we have used here the Kepler's law. Can you first see very well? Then I'll tell you. We have used here the Kepler's law because Kepler's law is very similar. Like when the planets are revolving around the sun or the satellites are revolving around the planet. In both situations, we can apply the Kepler's law very easy. Okay. So if we go to the question, which option is correct here? The correct option is here. Option A is the answer. Is it? So students, I hope so. This question based upon the Kepler's third law, also called law of what he told, law of periods, is very clear to you. Keep studying, keep growing.